Hey everybody, here's your video for the calibration of scientific glassware lab. We're going to work through the procedure pretty quickly today, and you should have out this document so that you can fill in along with us. So the first thing I'm going to do is show you the glassware that we'll be using today. We will use a 10 milliliter graduated cylinder, we will use a 10 milliliter syringe, and we will use a 50 milliliter beaker. And if you look at the scales of those three pieces of glassware that I've set down, you'll notice that the graduated cylinder is marked every 1/10 of a milliliter, syringe is every 0.2, and the beaker is every 10 milliliters. So that should allow you to make some predictions about which one of those is the most accurate. And we're going to test whether that's the case or not. So I'm going to try to fill up each one of these pieces of glassware with exactly 7.5 milliliters. But before I do that, I'm going to go ahead and weigh them so that I know their mass, and I can therefore subtract it later on. So let me go weigh this graduated cylinder. When I weigh the graduated cylinder, it looks like we have a mass of 36.990 grams. 36.990 grams. I'll also weigh my syringe. When I weigh that syringe, I'm getting a mass of 7.905 grams. And I'm going to weigh this beaker. When I weigh the beaker, that's coming out at 28.399 grams. All right, so we've got those masses. Now I'm going to work on filling each one up. So I'm going to go ahead and fill up my graduated cylinder. This will be a little strange. I'm going to use another beaker to fill it up as best I can. Looks like I have a little bit of extra, so I'm going to pour that out. And you guys have a pretty awkward down view, but this amount of water in this graduated cylinder is very close to 7.5. So I'm going to weigh it. And when I weigh it this time, the mass of the graduated cylinder plus water for the first trial is 44.463. 44.463 grams. If you're kind of thinking at home what to do next, you can pause here, right? You now know the mass of the graduated cylinder. You know the mass of the graduated cylinder with water. So if I do some subtraction of those two, I can figure out the mass of water by itself. So you should be able to fill in that box as well. Now, I did this lab earlier and actually did the other two trials. So instead of filling up these pieces of glassware every time with you, I'm just going to tell you that data. So my other trial, when I did it earlier, I had a mass of 44.502 grams. And my third trial was 44.468 grams. Now, obviously, I was using the same graduated cylinder so that we always have this same mass, so that the mass is the same when it's empty. Let me now fill a syringe. So when I fill the syringe, I just have a beaker of water here, and I will fill the syringe up until I hit 7.5. Hopefully we have no air bubbles. And I'm looking for where the black meets the water. And you can see that we're right on 7.5, where the black line here meets the water. I'm going to weigh this as well. When I find the mass of my syringe with water in it, it looks like it's 15.309 grams. 15.309. And I again did this earlier as well. So my other two trials were 15.401 grams and 15.299 grams. We also need to fill up a beaker. The beaker is pretty ugly in terms of ability to measure accurately, but I am going to try to measure this thing out to 7.5 milliliters. You can see we just have a little bit in the bottom, and obviously that scale is difficult to measure 7.5 with, but I've got about 7.5, and when I put that on the balance, my first value here is 37.309. 37.309 grams. I again did earlier trials, so one of them came in at 34.522 grams, and one came in at 38.155 grams. Just looking at those numbers should give you a hint as to which one of these might be the most versus least accurate. Now, I already said if we have the mass of the dry glassware that we have in all three of these places, we now have the masses recorded of the glassware plus water, so we can do some subtraction in every case to get the mass of water. Now, there's something that's really cool, which is that the density of water is 1 gram per milliliter. Every 1 gram weighs 1 milliliter. So if you have 5 milliliters of water, it's going to weigh 5 grams, and vice versa. If you have 5 grams of water, you know that it occupies a volume of 5 milliliters. So once we have the mass of water calculated via subtraction, that same number is actually going to be the volume of water. Because it's 1 gram for every 1 milliliter, we've just changed the unit. The volume of water is going to be in milliliters. Once you know your volume of water in milliliters, what I'd like you to do is calculate a percent error. And you'll notice that you're going to calculate a percent error for every one of these. And then once you get these 3% errors, you're going to find an average. This one is for the graduated cylinder. You'll find an average for the syringe, and so on for the beaker. So let's talk about that percent error. I'm going to flip to the back. And this space right here at the top, this is the space for you guys to do some work showing one of your percent error calculations. So as a reminder, percent error is a measure of how far we are from the target value. So we are going to take our measured value, we're going to subtract off our target value, and we're going to divide by our target value, because that's going to tell us how far away from our target we really were. I'll take the absolute value here, and I'll multiply times 100. As a reminder, the target value, this is going in both target spots, was 7.5 milliliters. That was my goal. That's what I was shooting for. So you can take one of your measurement values, subtract off the target, and divide by the target, multiply times 100, and those values are going to go in for your percent error in every single case. Then you'll take an average, and you'll figure out the average percent error for your graduated cylinder, for your syringe, and for your beaker. Now, the final thing to be aware of is that we had a class last year get some class data for us. Because we're all split up this year, we wanted to give you guys some pretty relevant class data that had quite a bit of sample size, a high sample size. And so for the graduated cylinder, it turns out last year that our class data set ran from 7.440 milliliters on the low end to 7.532 milliliters on the high end. Our syringe was 7.298 to 7.713, and our beaker was 4.348 to 9.209. So that class data can be really helpful for you. And just one other kind of side note to be aware of as you're starting through the work for this lab: between percent error that we calculated up here and range that I gave you right here, one of those corresponds to accuracy, one of those corresponds to precision. So I'm going to let you think about which one would correspond to accuracy and what accuracy is, and which one would correspond to precision and what the definition of precision is. So now you should be in a good spot to crunch the numbers and also answer these 5 questions below.